talked a little bit in advance about the lesson that you want to do on the laws of exponents.
Yes.
Right. So can you kind of tell me a little bit about, just a little bit more about what you're thinking? I know I have a little bit of notes about you want to use the depth and complexity icons before we actually do the lesson to make sure that they're familiar with all of these.
Okay.
So maybe during Brandon time,
Oh,
would that work?
Yeah, that'll work.
Okay. All right. So we're gonna use depth and complexity. We're gonna do laws of exponents, and then so what's your goal? Like, what do we want to do with it?
They have a hard time memorizing the rules, so maybe if they work and develop those rules, that they'll understand the process better.
You mean total student inquiry, where we're like, here's something, figure it out?
Yes.
Okay. Okay.
So I found an article from Dan Meyer,
Okay.
and it was something about, here's the headache, what's the aspirin? So to use that type of idea, where you give it to them ahead of time, like you just give them the problem and say, what's the answer?
Okay.
And then they'll look at it as far as language, they'll look at it as far as what patterns do they see, and then they'll develop a rule
Okay.
from that.
So do we want to have them do like a frame of the discipline to work on while they're
Yes.
doing that? Okay. So they need a frame with the icons. All right. And then you're going to have the hyperdoc.
Google Slides so that they can click into documents and then they can see on their screens what we're doing since we're one-to-one.
Okay. That's all.
Goal 2, develop critical thinking and creative abilities and problem-solving skills.
Okay.
The first one.
Okay.
Apply various techniques of problem solving.
Okay. We'll use that kind of as our benchmark that we're focusing on. All right. So I'll do the frame. You're going to have the hyperdoc. You've already found the problem that you want to start with. Now, are we starting with numbers or variables?
Numbers.
Okay.
And then moving to variables.
Okay. So, and giving them the concrete and then having it more with the variables, but they have to make that connection. I want us to make sure we talk about in our session with the kids, and then also like when we were talking, because we've both read the book about mathematical mindsets. And so I think there's some really good things in here. I think honestly, like a lot of this is stuff you already do, because you do a lot of the inquiry, the real world connections. And we have planned in the lesson to show some real world, how are you actually going to use this stuff. So I think that's important. And then one of the things that I liked in here a lot was they have setting up positive norms in the math classroom. And so, you know, I think, again, a lot of these things are things that I see in your classroom already. But I think this would be good to share and make sure we emphasize with the student. All right. Well, before the lesson, we'll touch base. I'll send you kind of what I've come up with for the mini lesson. But we want to schedule that for maybe 2 or 3 days before we actually do the actual lesson. And then we'll go from there.
Okay.
All right. Thank you. So today we're going to be talking about the ideas of depth and complexity. How many of you have ever heard this term before? A couple of you? Okay. So I know that some of the 6th grade teachers used it a little bit. Some of the teachers in elementary use them. But we are going to be using the icons of depth and complexity next week when the lesson that Ms. Bender and I are doing with you. And so we wanted to lay the groundwork today just to remind you what they are, what they stand for, and that kind of stuff. So with the ideas of depth and complexity is that we are going deeper into what we're talking about. And then as we go deeper, we also want to get more complex with our ideas. So we're not just trying to scratch the surface, we're trying to really have a better understanding of what our topic is. Right, so we're going to start with depth. So the easiest part of it, or like I guess maybe the least complex, is language of the discipline. And so I have a really fancy word for you here, nomenclature vocabulary. And what that means is that we use the vocabulary that experts in the discipline use to discuss the events, the ideas, that kind of stuff. So when we're thinking about math, what are some words that mathematicians would use? Mary Kat? Any words, mathematicians.
Any words?
Any words.
Percentages or
Okay.
decimals or constants.
Okay. Aurora? Huh?
The difference of?
The difference of
Multiplication.
multiplication, exponent,
Polynomial.
binomial, less than, polynomial. Okay. Do people have different perspectives on math?
Yes.
Yeah. People who struggled with math in school, do they like it when they think about math now? No. Okay. If you had parents who struggled with math in school, they might have shared like some of those negative feelings with you. And that might have even kind of changed how you view the idea of math. Whereas people who parents had pretty good success in it, you might feel differently about math than other students do. Justin? So these, you might see a couple of these next week. So we have application, balance, conversion, expressions, extension, imbalance, inquiry, proofs, and strategies. If we use one of these and you're not familiar with it, we'll explain it in advance. What we're doing today is an inquiry-based lesson. We wanted to incorporate the depth and complexity that we talked about last week. Remember, we reviewed with icons, meant, things like that. And so we have a lesson today that is called, so that's what we're calling it, here's the problem, what's the rule? There's an old expression. If you give a man a fish and you feed him for a day. If you teach a man to fish, you feed him for a lifetime. So I want you to think about that for a minute and think about what you think that means.
I said if you do the work for someone, they don't. That only gives them the answer. But if you show them the steps, they know how to do it now.
Okay. Jenna, you want to ask it real quick?
It's like, for example, for maybe your question 9, you could just give them the answer, but they don't know how to do it. But if you actually like go through them step by step how to do it, they'll know how to do it next time.
If you think about, like, in math and in other subjects, like, throughout your school career, there have probably been times when someone said, here, this is what you need to do it like this, but you don't really understand it, right? One of the things that our goal for today is to have you investigate and think about something new, and really make some connections to it. Ms. Bender and I have been reading a book, it's called Mathematical Mindset, and one of the ideas in that is that a lot of times in math, we ever think who finishes first wins, right? How many of you feel like that? Like, I'm just gonna get it done, I'm gonna get it, and you don't really think about the connections. But really, math was not meant to be like that. Math was designed for you to take your time and make the connections. True mathematicians, some of them may spend their whole lives on like one problem. And I'm not exaggerating when I say that. They so focus and so deeply go into things. So we want to remind you that you need to make a connection to what you're doing. And that is why we're doing this. Instead of just giving you the information, which we could, we want to have you kind of explore it on your own and come up with some connections and use the icons to help understand it. Okay. So again, remember we saw these icons last week? We're starting off with student inquiry to solve the problem. So you're going to be investigating it. We're not going to tell you the answer right away. And for some of you, that might be frustrating. But we're going to have you work together and explore. I see some heads nodding when I said that, to make those connections. So you're going to be using a frame first. And we have them work together tables. Okay. And so think about how do patterns allow us to describe and or solve a variety of problems. So your frame, just to remind you, you have the 3 question marks, and what does that mean?
What type of questions?
Unanswered question.
Unanswered question. All right.
So when you start doing your grouping and talking, there's something called a thinking map that you're going to come back to. So can you click on the link for me, please, the language one? So one person in your group needs to be the person who controls the document. So right now, pick the person in your group who's going to control the document. All right, so here's your first problem. It says, here's the problem, what is the pattern? And it has 2 sets of numbers. Before we do anything, you guys need to talk about the language of the discipline that's going to help you solve that problem. So I'm going to give you about 5 minutes on your frame. I want you to list all the language and discipline that you think you need in order to solve that problem.
Right.
But polynomials have their own set of rules. They're different than equations.
That has to be 2 terms.
No, a monomial is 1 term.
Yeah.
A binomial
Is 2 terms. A trinomial is 3.
But we don't even need to know the word polynomial just to solve that.
But polynomials have their own rules.
But do we even know if it's a polynomial?
Wait a second.
Typing. It is now your responsibility on your colored Post-it. It's an electronic Post-it. You need to type in the main language that your group got. Just one. No, as many as you have. You have to stay within the. Aiden, you need to take your name off the slide.
We did write down her. We wrote exponent.
All right, somebody give me a word that is repeated. Zachary.
Exponent.
Someone.
Ashley, what's another one?
Degree.
Degree.
Give me another one.
Ava?
So now what you're gonna do, it says, here's the problem, what's the pattern? Based on the common words that you came up with, I'm gonna nix polynomial. I don't want that one in there. Okay? So based on the language that you came up with and these 2 problems, you're going to go up to the whiteboard that I assigned you, and you are going to find the pattern based on the big idea of exponents. Does everybody understand that? You will have 10 minutes, I'll check in, and then if you need more, we'll do 5 more. And everybody should be collaborating and working, showing your thinking on the board. No sneaking peeks at other people's boards. All right, go.
What did you do, Ava?
So basically, I just like lined up like all the 3s and then all the 2s, and then I made each one like its own problem. So then 3 divided by 3 would equal 1, and then like all of them would equal 1. So the problem would just equal 1.
What I see is that if you look at the exponents on top, you have 5, 3, 2, 2, and when you add those up, it is the same thing as 3, 5, 4 that's on the bottom. My question to you is, do they have the same base?
They do have the same base.
They do?
No, the second sheet doesn't.
No, since there are the same amount of 3s
got
and
it.
2s on the bottom and top, they would equal the same number, and then when divided, they would both cancel each other out and equal 1.
Okay, thank you, Dax.
16.
1.
Oh, I thought he got one.
No. Okay. So you may not expand them. You may not do 2 to the 3rd power is what?
2 times 2.
8. You may not use integers like that. This is what you must use, and you must be able to come up with the rule on how to get this to equal 1.
Ooh, got it.
All right, go. 7 minutes.
3, 2, 5. Wait, 3, 2, 5.
They're the same thing.
3, 2, 5. Oh, wait,
3, 2.
Is there only one rule? 3, 2, 5.
So then it equal 1.
Boom.
All right, Justin.
I'm in your group and I don't understand.
You need to show it mathematically that they're the same. That is not showing me mathematically.
Yeah, so you have to time.
Guys, can somebody divide it?
No calculator.
Well,
We couldn't do that.
yeah.
We couldn't do that.
So.
Are we allowed to do
I got
some
it.
3 times 3 times 3 thing? Just to solve it?
No.
3 times.
3 to the 7th, 2 to the 5th, 3 to the 7th, 2 to the 5th. So you needed to focus on the exponents. And you need it to equal 1. Someone tell me when you're doing exponents, what exponent, a base to an exponent, will always equal 1? The base to what exponent will always equal 1?
One.
Zero.
Well, which one is it, 0 or 1?
One.
Zero.
Zero. Both. What?
Let's okay, let's think about it. Which one is it?
Wait, 2 to the 0.
What?
1. It's 1.
Jenna?
Oh, zero.
So 2 to the first power is always going to equal 1?
Oh no, I'm sorry, I missed 0.
Let's try again.
Zero.
Which one is it?
Zero.
Okay, so I need somehow for this numerator to be a power. So some power to 0. And I need this one to be some power to 0. Oh. And isn't that going to give me 1? Yep. Because 1 over 1 is 1, right?
So this group over here was on a really good track. They just couldn't quite
Explain it.
get all the way there.
So whenever you had it, ignore the orange. Whenever you had it, it was over here, and what you would do is you would put that back up here,
So
and you
this
subtract
7
the
goes up here, and you get 3 to the 7th minus 7.
yeah, and then a number minus itself is always 0. So, and then you do the same thing with the other one, the 2 to the 5th power. You just grab from the bottom, which would also equal 0, and then just 3 minus 2 is 1.
Not 3 minus 2, no. What's 3 to the 0 power?
1.
And what's 2 to the 0 power? 1. And 1 times 1 is 1. So to finish my question stem, Justin, when you're dividing like bases, you subtract the what? Well, thank you, Lawrence. Okay, we're still not done, and we're going to run out of time.
Wait.
In life, it's never this easy.
Easy.
This was not easy.
So in real life, you only get variables. So using the rule that you just formulated, simplify that.
Oh, I got it.
Next.
5. 8 to the third.
8 to the third.
A's? You gotta.
Wait,
Okay. All you have to do is add variable. See, I fixed that. The X and
If you do not understand what we're talking about, raise your hand.
over 1.
Nixon, why did you put the B at the bottom? Huh? Why did you put the B back at the bottom?
You didn't see that. And Sarah's wrong. She just said why.
Alright, one group is done.
What you got?
We're done. So we got
Let's see.
1.
So laws of exponents is what your next typodoc is on. You have already taken care of this property and this property. Okay, so you'll do some more work on it and you'll get your video notes. But we're going to end up learning the rest of the properties also.
We talked about the 0 exponent property too today, though.
Oh yeah, we did. Okay, so really you've taken care of 3 and we have 3 more to go. Miss Scott put a link on here, and it talks about why our exponents are important. And then, it goes through an entire. And a lot of these I knew. Like, I knew that there's exponents in computers and computer games. Exponential growth and decay, you guys will be learning about. That one I don't know. Compound interest, I'm good with. Population increase, you guys will learn about that too. Bacterial growth. Spread of viruses. Energy release, I guess I never thought about it, but isn't it E equals MC squared?
Yeah.
Okay, so that does have some exponential stuff in it.